Hello everyone, we are going to present our product Dronification of Crop Insurer in Redis Hackathon powered by Drone, Redis, AI and Cloud Technology. I am Piyush Jain leading this team, having 16 years of work experience in the technology. I have used .NET, Redis, Cloud, Python, AI, ML. Along with me, I have Brijesh Kumar, an experienced engineer, Chirag Khanna is a data engineer, Sagar Shankla is a microservice engineer. We have taken a use case of crop insurance sector because they are facing a lot of challenges in terms of poor risk assessment because of lack of data, slow claim process because of the remote location inspection, and some other areas like difficult to find a specialist to farm inspection and all. So due to all these issues, the cost and the time is increased a lot for the insurer. From the past analytical data, we have seen that the losses of crop insurer increase across the world. We have taken a use case of fire on a field for our claim journey. Along with that, we have chosen a drone technology because drone market in agriculture industry is a high. Let's check the our high level architecture diagram for this MVP. We have created a crop insurer portal where insurer can do the customer registration, policy creation, and claim settlement. Along with that, insurer has a capability to live scan the land from this portal. So he click on the start inspection, then a unique ID will be generated and pass into the Redis stream where a drone container is running, which can pass this signal to the drone, and drone start flying. First, drone will create a path based on the data provided by the farmer. Now to simulate this demo, we have created the virtual land using a AirSim simulator. We are using for Unreal Engine for planting a different Unreal objects like farming land, unfertile land, non-fertile land, high volume land, and a high crop land, low crop land like that. When uh, when a drone is fly on this virtual land, it will start capturing the images. These images are real time passing to the Redis stream where Redis Docker container is run. On the other hand, we have created a pre-trained model using a Microsoft Custom Vision service, which can help to identify different type of objects in the images like high cropland, low cropland, high crop, fertile land or fertile land like that. And this trained model, which is called TensorFlow model, is passed on to the Redis Docker container where Redis AI will take the raw images from the drone and with map this to the trained model and convert all the images to the modeled images. These modeled images are stored in the Azure Blob storage, and all the properties of the images will be passed on to the Redis streaming, which where our front end app is continuously listening and showing all the data of this inspection. Once drone finish the scanning of the land, then all data will be passed to the backend system using a microservice architecture. This microservice architecture we have divided into different entity. So just like a customer API container, the inspection API, policy API. In this microservice architecture is built on Java Spring Boot framework, which in turn using Redis cache, Redis search, and Redis JSON. Now, uh, this backend API will do all the inspection of a data, and based on this data, the sum assured and the premium will be calculated and pass on to the front end app where insurer and farmer can agree, and then insurer can create the new policy for that. So as you see with this, with the help of this complete product, the insurer can do the live farm inspection and all the streaming are coming to his in almost in real time. So based on that, he can take a decision and do an inspection by seeing by sitting in his office. So it's a win situation for both farmer and the insurer. Now let's check out the quick demo for this. So the demo flow consists of 4 steps. In step 1, we will do the customer registration. In step 2, we'll create the policy based on the drone inspected data. In the intermediate step, we'll do another inspection using a drone to ensure that that is harvested is up to the good quality or not, which will provide a recommendation to the farmer so that he can improve its crop. And the last step, we are showing how the claim process can be initiated and using a drone, how the claim can be generated. Let's check out the live demo now. Okay, so here is the insurer portal that we have. Insurer can log in with his credential to this portal, and there is inside the portal now. So here you see that there are some prospect customers and there are some policyholder registered already. Now, but let's start with the adding new customer this time. So here we'll capture all the basic information of the customer, including his name and email and all. And most importantly, we are taking what type of crop that he's trying to put on his land this time, and his location, which is helping to further calculation. And we also taking the premium rate and expected yield and the market price of the wheat in that area. And the coverage period is a 4 months, as this is a wheat crop, so it will be a period of 4 months. And then we'll most importantly will capture the latitude and longitude as well, which will help drones to fly in a correct direction. So yeah, so here we see the customer is registered. Now we'll start with the new inspection for this customer. Click on the start inspection button. This will send and a unique inspection ID to the Redis streaming. And now let's understand the background process, how drone works and other streaming platform works. So over to Chirag.
So in order for the drone to fly, it needs to receive the signal from the front-end app in the form of the Redis stream. As you can see here, client is waiting to take off. Client in our case is drone, and it is waiting for the stream. There is no input from the stream yet. And you can see we have received the signal from the stream with the inspection ID of 5678960, and drone is ready to fly now, and the stream has been acknowledged as well. As you can see, drone has started flying now. Now it is basically capturing the images of the land in the interval of the 2 seconds and sending it to the Redis streams. So this is the Redis stream on which the data from the drone captured is being sent. And the data which is coming from the drone, it has following attributes: weather, wind speed, image name, and the image. In the image, we have the complete binary encoded format of the image. Now at this stream, we have basically attached the listener using the Redis gear, which is basically modeling the images using the TensorFlow at the Redis AI. This TensorFlow model we have created using the custom vision. So let me show you the custom vision. So this is a custom vision model against which we have following categories on which we have modeled our images. So we have cultivated land, damaged area, high quality crop, infertile land, low quality crop, and others. So let me show you one of the category against which we have modeled our. So this is our image, and whenever this kind of area is spotted in the image, it will be recognized as a cultivated land. And similarly, let me show you one more example. So these kind of the black areas are the damage areas. So this will be, whenever these spots are recognized in the images, this will be recognized as the damage area, and these are the high quality crops. Now the data from this trained model is basically stored to the output stream, which is predictions in our case. So let me show you the output, modeled output, which is coming from this trained model. This is an output model prediction stream on which the output is going. So as you can see here, we have following attributes in this case: cultivated land, damage area, high quality crop, and some other columns such as all the categories: infertile land, low quality crop, and the file name as well. So as you can see here, the cultivated land is 99.6%, since the most of the land which we have over which the drone was flying was cultivated. So we are getting the percentage of 99 here. And we are getting the file name. On this file name, we are basically, this is the URL of the Azure Blob storage on which we are storing the modeled image. Now at this stream, Our front end app is basically listening to this stream, and it is getting the data from this stream in the real time on the front end. So let me show you our modeled image on the Azure Blob Storage. This is our Azure Blob Storage, and our inspection ID was 5678960. This is our all the images which are processed are being saved here. So let me just open one of the images. As you can see here, since the most of the land was cultivated, so we are getting the percentage of 99 as the most is region is being covered as cultivated, and our drone is working perfectly fine and is able to recognize this as a cultivated land.
Now, as this drone stop flying, all the images are or all the data is loaded on the front end, as you see here. Here you see that the base IDV value will be this value, but after the inspection we found that the only cultivated land is 85%. So the based on this 85%, the value, the sum assured that we can offer to this customer is this much, and based on this the single premium is this value. So now if insurer and customer is agree on this, then we can create that policy. So let's create the policy now. You see the policy is created and all the information is showing correctly here. Now let's we'll have one history record also. Now we can also do the intermediate inspection of the property, which basically help to to the farmers to understand if anything goes wrong, or if anything goes wrong, then we can understand like what can be improved further. So this inspection will provide the recommendation of the recommendation to the farmers and insurer. So as you see, the drone is flying, and it all the land is look like a high crop land created, but still like you can see there are some low crop images are low crop land is also there. So let's see how drone taken all the images and capture it correctly, and we'll see the average value on the front end after drone stop the flow. So drone is stopped now, and you see here this time the original sum assured value is this value, but after some inspection, intermediate inspection, we found that it's reduced a bit. It means that the high quality crop is around 80%, but initially when we scan a land, it will around 85%. So we see there are some low crop images. So we'll give the recommendation to the insurer or a farmer to improve the crop quality if during the course of a time. So this inspection will help in that. So we'll just save this inspection for intermediate purposes. Now let's say a customer come for any claim at the last step. So we'll again do the start inspections, again send a unique ID to the Redis stream, and then drone start scanning the land. And this time we see, oh, the land is completely burned out. The drone is capturing all the images, which is a kind of damage area. But yeah, we can see there are some still high quality crop is there in the land. So drone will capture all the images correctly and give the percentage value. So based on that percentage value, we can exactly give the claim to the customer. So let's see, when the drone stop flying, then we can see the actual IDVR value and the sum assured what it conclude. We can see here the damage area is around 82% right now, but it's keep increasing and decreasing based on the different images that drone is capturing. It's still functioning, the drone flying, so let's wait for it settle down. Yeah, so it's settled down now and stop playing, and you can see that the current IDV value is only 20. It means that the like around 74% is a damage area, but when we created a policy, it was like 85%. So the 11% is still a high quality land we can mark it up. So based on that calculation, it is reduce this amount from the original sum assured and give it the claim to the end user. So it's a fair deal for everyone, and we can convert that into a claim this time. That's ends the demo. After looking at the demo, we understand the benefit of this MVP product. So like 30% saving on the coverage amount for insurer, around 35% saving on the premium for farmer, and around 40% amount saved on the claim paid by the insurer with our product. The other benefits of this MVP include transparent information, inspection efficiency, accurate and informed decision for claim and sum assured. Inspection history can be get from the portal any point of time. This is best in class solution which is highly scalable based on Redis and Azure cloud technology. We also use Redis modules like Redis Streaming, Redis Gear, Redis AI to provide a real-time image processing which make this product more efficient and robust, which we are not able to see with any other system. It also provides an intelligent recommendation to the insurer and the farmer, which helps farmer to improve their crop quality. So in nutshell, it's a win-win solution for both crop insurer and farmer. Thank you for your attention. I understand this product involve a lot of different system. So we would love to have a 45-minute live session with the panel to go each and every module in detail. Thank you.